Welcome back. Now that we've hopefully learned a little bit about Newton's laws, let's apply them to solve some problems. So let's say I have I don't know, some kind of vehicle, a car, a motorcycle or something, and let's say its mass is 500 grams. And let's say that I can accelerate this vehicle at an acceleration of, I don't know, 3 centimeters per second squared. What's the force that I need to apply to this mass to accelerate it at this speed? And we want the answer in newtons. So what's the force? So we're just going to use Newton's second law. Newton's second law tells us force is equal to mass times acceleration. So you might want to, or you might be tempted, just to multiply mass times acceleration. You'd get force is equal to, let's see, 500 grams times 3 centimeters per second squared, and you would get force is equal to 1500 gram centimeters per second squared. And if you did this, you would be right, although your answer would not be newtons, and now you would have to somehow try to convert this set of units to newtons. And what are newtons? Well, we learned when we did Newton's laws that a newton, so 1 newton, is equal to 1 kilogram meter per second squared. So somehow we have to convert the grams to kilograms, and we have to convert the centimeters to meters. We could do it after the fact here, or what I find it easier to do is actually to convert the mass and the acceleration units first, and then just do the F equals ma. So what's 500 grams in kilograms? Well, 500 grams is half. A kilogram is 1,000 grams, right? So 500 is going to be half a kilogram, right? 1 kilogram is 1,000 grams, so 0.5 kilograms is 500 grams. Similarly, 3 centimeters is how many meters? Well, 1 meter is 300. 1 meter. I think I'm dehydrated. 1 meter is 100 centimeters, right? So 3 centimeters is 0.03 meters per second squared. Hopefully, this makes sense to you. 3 centimeters is 0.03 meters. And now we are ready. We have our mass in kilograms, and we have our acceleration in meters per second squared. And if this is confusing, you should watch the units videos, because this is all I'm doing. I'm just doing unit conversion. So let's go back to force equals mass times acceleration. So the force is equal to 0.5 kilograms. 0.5 kilograms times the acceleration, which is 0.03 meters per second squared. And this equals, what's 0.5 times 0.03? I'll do it down here just because multiplying decimals seems to be a problem for a lot of people, including myself many times. So what you do, you just multiply the numbers, right? 5 times 0.3, or 5 times 3 is 15. And then how many points do we have behind the decimal? How many digits behind the decimal? Let's see, we have 1, 2, 3. So 1, 2, 3. Right? We have to add the 0 because we need 3 spaces behind the decimal point. So we get the force is equal to 0.015 kilogram meters per second squared. And this is a newton. So the force is equal to 0.015 newtons. Let's do another problem. And this one's going to be, and actually I think you'll find most of the difficult Newton's laws problems or force problems, they're just some combination of making sure you get the units right. And when we're talking about in one dimension, it's the difficult part is usually getting the units right, or just the math, just the algebra. So if you have trouble with this, it's usually because you have to just brush up a little bit on the algebra. The physics itself is just force equals mass times acceleration, as we will see in this problem. So let's say that when I apply some force, some particular force, I use this little 0 here, so I call that force F sub 0. So this means a particular force, that this is some value. When I apply that force to some mass, let's call that m sub 0, I get some acceleration. I get acceleration a sub 0. Right? We could have put numbers here. We could have said, well, if I apply a force of 10 newtons to a mass of, I don't know, to a mass of, let's say, 2 kilograms, I have an acceleration of 5 meters per second squared. But I'm just doing this because this could be any relationship. And let's say the problem tells us that when I put another mass with this first mass, so let's say that, let me draw this diagram. So here's my mass, m sub 0. When I apply a force of f sub 0 to it, I get an acceleration of a sub 0. And now the problem tells us when I add another mass, so let's say I stack it up and we're like in an ice skating ring or something, and I stack another mass up here, and let's call this mass m1. When I stack another mass on here, so let me redraw it actually down here, because it's a different case, and I apply the same force, so I apply the same force, and now I have this new mass on here. I'll do it in, it's m1. The problem tells us that my new acceleration is 1/5 the original acceleration. So it's 1/5 of whatever this was. So it's 1/5 a sub 0. So the question is, what is the ratio of m sub 0 to m sub 1? So m sub 0 to m sub 1 is equal to what? And I'm going to keep it in abstract variables just to confuse you, and then I'll show you that you could actually substitute numbers and the problem becomes a little easier. And you might want to pause it and try it for yourself. So let's work it through. So we know we have this relationship to start off with. And just for simplicity, let's write what m sub 0 is in terms of f and a. So we just divide both sides by a sub 0, and you get f sub 0 divided by a sub 0 is equal to m sub 0. Good. So let's just put that aside for a second. And let's do that same relationship here with this. So here, this relationship tells us that f sub 0 is equal to m1 plus m0 and times this new acceleration, which is 1/5 a sub 0. 1/5 a sub 0. And so if we divide both sides by this term right here, we get, dividing by 1/5 is the same thing as multiplying by 5. So you get 5 f sub 0 over a sub 0 is equal to m1 plus m0, right? I just divided both sides by this term right here. Well, what's f sub 0? What's this? Let me switch colors again. What's f sub 0 divided by a sub 0? What's here? It's what we solved for in the beginning, right? We just got it from this relationship. So we could substitute 5 times f sub 0 divided by a sub 0 is the same thing as 5 times m0. So let me draw a line here. So we have a new relationship. 5m0 is equal to m1 plus m0. All I did is I substituted this for this, or this for that, and I used this relationship, which we got in the beginning, to do that. And now what do we have? We have 5m sub 0 is equal to m1 plus m0. We could subtract m0 from both sides. And you get 4m0 is equal to m1. You could divide both sides, or you could divide both sides by m0, and you get 4 is equal to m1 over m0. And you can invert this relationship, and you can get m0 over m sub 1 is equal to 1/4. So what we learned is the ratio of the old mass to the new mass is 1:4, and that's the problem. And actually, I will leave it for you as an exercise to figure out, to just do the same problem using the numbers. Actually, I will do that actually in the next video, just to show you that that actually would have been a simple way to do it. But it's good to get used to this, just so you can solve things in general terms. I'll see you in the next video.